What is quantum entanglement? Have you ever had a momentary telepathy with distant relatives and friends? Is it genetic involvement or an exclusive sixth sense? A similar phenomenon has also occurred in the quantum world, known as quantum entanglement. Quantum entanglement refers to the existence of a special correlation between two or more particles. When we measure one particle, we can know the state of the other particle, even if there is no physical connection between them. In the previous video, we talked about the century-long debate between Einstein and the representative of the quantum school, Bohr, but there was no result. So in 1951, physicist Bohm proposed the hidden variable theory, which means that behind the probability in the microscopic world lies an undiscovered variable. Once we discover this hidden variable, we can break Heisenberg's uncertainty language and accurately grasp the laws of motion in the quantum world. In 1964, physicist Bell proposed the Bell inequality to test the existence of hidden variables in quantum entanglement. The basic idea of Bell's inequality is that if there are hidden variables, the result of quantum entanglement should satisfy certain statistical laws, namely Bell's inequality. If there are no hidden variables, then the result of quantum entanglement should violate Bell's inequality. Therefore, by measuring the results of quantum entanglement through experiments and comparing them with Bell's inequality, we can determine whether there are hidden variables. In 1969, physicist Clauser and his collaborators further developed the Bell inequality, CHSH inequality, making it more applicable for practical experimental verification. In 1982, physicist Aspect and his collaborators completed 3 experiments on entangled photons and observed that the CHSH inequality did not hold, i.e. the Bell inequality did not hold, but there were still some experimental loopholes. In 1997, physicist Zeilinger led a research team to further improve the entangled photon experiment and filled in all experimental loopholes, verifying with extremely high accuracy the non-existence of the CHSH inequality. In 2022, the Nobel Prize in Physics was awarded to Alain Aspect, John F. Clauser, and Anton Zeilinger for their use of entangled photons in experiments to verify the Bell inequality and pioneer quantum information science. Specifically, these 3 individuals conducted experiments based on the idea of the EPR paradox, selecting a pair of entangled photons as particles A and B, and detecting the states of the 2 particles separately at a distance. And when they repeated the experiment time and time again, they finally found that there was indeed a wonderful correlation between particles A and B, and the results of probability and statistical calculations did indeed verify the validity of the CHSH inequality. At this point, the classical physics school is indeed wrong, and the theory of latent variables is also wrong. The quantum entanglement theory of quantum mechanics, although puzzling, is indeed correct. The essence of the microscopic quantum world is probability. To this day, although humans have not yet mastered the basic mechanism of quantum entanglement, related technologies based on quantum theory are constantly developing, such as utilizing the wonderful properties of quantum entanglement to achieve secure communication, accelerate quantum computing, and achieve highly sensitive quantum sensors. At this point, the physics series collection has come to an end. Next time, we will discuss some incredible social experiments.